All right, welcome to using contract first development for the first person API to solve real world use cases with Jared Kasanovic from Do It Enterprise Integration. I am Amanda Thornton, a software developer over at Space Science and Engineering Center, very anxious to use the person API at some point. And I will be moderating today's session. If you have questions, please put them in chat. I will ask Jared throughout if he wishes, or we can hold him till the end. Or we can answer them later if we run out of time. I'll hand it over to Jared in a second to introduce himself, but we are recording this, as you may have heard, and an accessible video will be available for viewing on the IT Professionals website in the coming weeks. Jared, take it away.
All right, thank you. Yeah, welcome everyone, and thanks for staying to the tail end of the conference here on a Friday afternoon to attend this. So really appreciate that. Like Amanda said, my name is Jared Kasanovic, and I work in the Do It Enterprise Integration group. A little bit about our group: we implement integrations for departments around campus. We also provide tooling and infrastructure so that distributed departments can implement their own integrations. We do some consulting work, API development, and we also work closely with the Office of the Registrar for more student-focused applications. Yeah, today's presentation, I'm going to be talking about APIs, how to design APIs. I'm going to talk about a little bit about the person API, which is what my team has been working on for the better part of this year. So some of the outcomes: what is an API? Why should they be used? We're going to talk about some other alternatives to API-based integrations. And like I said, basic knowledge of API design, and then understanding of what the person API is and how to use it. I'll go through a demo at the end. I'll also leave some time at the end for questions. If we could just ask all the questions at the end or catch up on them at the end, that'd be great. I might answer the question during the presentation that someone might have. So yeah, we'll leave time for that. So first, jumping into an overview about APIs. What are APIs? So they stand for Application Programming Interface, and can basically be thought of as a defined interface for integrating systems. So they're kind of like the glue layer between an application or a system that wants to interact with another one. APIs are everywhere. We use them every day. Like for example, looking up flights on like Google Flights, it pulls up airline information for all the different airlines. Google Flights is using each of those airlines' APIs to get flight data and ticketing data. Another example is using Uber to get a ride. Uber is using Google Maps API to get mapping data. It's using Stripe, a payment system. It's using their API to handle payments. These are just a few examples of where APIs are used. And then APIs are great, but if people don't know they exist or where to find them or where to get access to them, then they're not really that useful. So another component that's often used in the same context as APIs is a developer portal. And that's a platform for discovering and getting access to APIs for a particular company or organization or department. So some of the benefits of using APIs for integrating systems: it simplifies the interactions between complex systems. APIs are meant for people outside of a particular department or someone that might not have knowledge of a complex system to be able to interact with that system from their application. So it's meant to simplify those interactions. It's also helpful for making integrations more resilient. So because APIs abstract a lot of details, the API can be protected from backend upgrades or changes in that system. Obviously, big changes can change the API, but APIs are meant to help isolate people that use it from systems that need to upgrade behind the scenes. Another benefit is that they're very reusable, or meant to be at least. So APIs can be, a single API can be used for multiple different use cases. And that's when they start being beneficial, is being able to create one API that can be used for multiple different use cases. So there's a lot of different kinds of APIs, but in most contexts you'll hear them about in this presentation, we'll be talking about ones that operate over HTTP which stands for Hypertext Transfer Protocol, but I'm not going to get into that right now. It's basically, we're talking about APIs that operate using the same standards of the web. So the same standards we use to access websites in our web browser, that same protocol is what we're talking about here when we want to access APIs. So these kinds of APIs organize content into resources. So resources can be like a plural noun, like for the person API, it's people. We'll get into an example here with a restaurant, like so the resource might be orders or menu or something like that. And then those resources can be interacted with using methods. So we can get a resource, to get its information. We can send what's called a post request to create a new resource, another method to update it. So that's kind of the two main things at play here for kind of a high level overview. So we'll jump into an example of what an API might look like in the real world. So we have our example here is going to be a restaurant API. We're going to create an order and check on its status. So the resource we're going to use to do this is called orders. So first we'll send a post request to orders. That's basically saying we want to create a new order, and we're sending it to this URL. And in that request, we're sending a request body, which is all the content needed to create that resource. So for example, we need the order by a certain time. And then here's the items that we're including in that order. So 2 chicken tacos. And then when we send that request to the API, we'll wait for a response, usually within a second or so. And then that will respond with a status code. In this case, 201 means the resource was created. And then the response body with some other helpful information, such as the status. And then what's helpful here is an order link so that we know where to check on the status of this specific order that we just created. So now that we created the order, we can go in and check on its status using that link that we just got. So we'll send a GET request to get the order status for that particular order. And then the response, we'll see it's ready for pickup. And then it also has that same order link just to match the consistency of the response body for the other request. So that's an example. We sent 2 API requests here, one to create the order and the other to check on its status. And that's, a common example of an API. I mean, it's, it can be as simple as that. For example, maybe this would be used by like an ordering system like Grubhub or DoorDash or something to interact with a restaurant. So just a fake example, just to show what an API might look like. So that's a little overview about APIs. Next, we'll go into some other integration methods that are pretty common as an alternative to APIs. One of those is flat files. So this involves populating a file and transferring that file to a server, or maybe getting a file from that server and processing it in our own system. This is basically a collection of rows and columns, delimited by commas or spaces, mostly used for bulk integration and running on a scheduled basis, like once a day or once an hour or something like that. So these are pretty common. One of the reasons is that a lot of vendors, like for software as a service providers, only have this as their integration method. So some might just create this because it's a little bit simpler from the provider perspective to create, but there are some drawbacks. Slow feedback is one of them. So for example, when we sent an API request to create an order, we got that really fast feedback about whether it was created, or if not, maybe there was an error with the order. With flat file integrations, you kind of have to go back after the fact to make sure everything was uploaded correctly. If you're lucky, maybe the vendor gives you like an error file that you can look at, but there is slow feedback if the data wasn't valid. The structure is limited. Like you saw in the API example, we can have kind of nested objects and lists. Most of the time, these files are just restricted to rows and columns, and then you might have multiple files to represent relational data. And then limited standards. Each vendor or system might implement a flat file integration a little bit differently. Same with APIs, but there's a little more flexibility, and it can lead to more customization for the integration that you want to build. Another example is that's pretty common is interacting directly with the database. So this is pretty similar with file integrations in that it's mostly used for integrating a bulk amount of data. And then it's mostly involves getting or inserting data directly into a database. This is also pretty common. One drawback is that you need to have a constant connection to a database or start a connection and then maintain that. This works well if you're talking about working on an integration like within the same data center, or if it's in the cloud, maybe in the same region. But when you start trying to transfer data, from and to multiple locations, this can get a little more volatile just because you need to maintain those connections. You have to be a little more careful about reusing or connections or reestablishing connections if they fail. This is also more vendor dependent. So when we're going directly to the database level, we often need to make sure whatever system is trying to integrate with the database needs to be compatible with that database, depending on the vendor provider. And then when we're interacting directly with the database, it's easier to leak details. One of the benefits of APIs we talked about was being able to abstract some of those underlying details of a system so that integrations can be more resilient. When we're interacting directly with the database, you just need to be a little more careful about not to leak those details and provide that abstraction layer that helps consumers of an integration not break or have to change every time there's a change in the structure or an upgrade or something like that. So jumping back into APIs, we'll talk about API design. The API design technique that our team likes to do is called contract first API development. And that basically involves designing what the API will look like for the consumer first before going in and implementing code or maybe setting up a database or whatever might be involved. So when we develop that contract, it's also can be thought of like as the API specification or API documentation. We're showing why someone might want to interact with the API and why they might want to use it. So we're showing them what it looks like to use this API and why they might want to use it in the first place. And we also want to give users a full idea of how to use and get access to the API. If it's not public data, what are the steps I need to do to get access to this? That should all be documented in the API. And when we start designing an API, these are the things we want to start with first. We want to make sure our API doesn't rely on any out-of-band information. All the information should be in the API specification in that contract, or at least linked out to it, maybe in a separate KB document or external documentation. Say what you will about Jeff Bezos, but like one of his things with Amazon Web Services when he was telling people to create APIs was to design APIs so the whole world can see it. So make sure you have the right documentation and the right authorization so that anyone, not just someone that's maybe across the hall or something, can use this thing. Make sure you're designing it so it doesn't require any sort of out-of-band context. So when we're designing an API, we want to start with user needs. And I might use the word consumer interchangeably with user, but it's the same thing. You'll hear API consumer or API user referring to the same thing there. So there's some things we want to do and some things we want to avoid with designing an API. So first, one thing to avoid is designing an API based on how the database is structured. Like I said, we want to be careful not to expose those internal details of the database to the API. Instead, we want to make sure we're designing the API to meet the needs of the consumer. So really figuring out what those needs are and then designing the API based on that. So from a user-driven perspective. Another thing we want to avoid is building an API from the provider's perspective. Someone who's providing data, maybe administering a system, will have really good knowledge of how that data is structured and looks. But that's not the only thing we want to consider with an API. It's great if an API perfectly represents its data structure, but if it doesn't make sense to consumers, then it's not that useful. I'll just keep going down the list of things to avoid. Another thing is auto-generating an API. There are lots of tools out there that can look at a database and generate generate an API on top of that, and maybe even generate some API documentation. These kind of tools are mostly optimized for the provider. It's mostly optimized to make generating an API easier, but it doesn't optimize for making it more usable or driving towards a solution that a actual user needs. And the last thing to avoid here, prioritizing API features based only on what's easiest to implement. This should definitely be a factor when we're prioritizing what we're actually going to do. But we also want to consider other things such as what use cases we're actually driving towards. Besides what might just be easy to implement from a technology perspective. So I'm going back on the right side here, things we want to do instead. So we do want to identify common use cases for the API. Like I said, APIs should be reusable. So it's really helpful to identify those use cases that we can do. We can implement, maybe one feature and it solves multiple use cases. We want to design iteratively. So that's the whole point with contract first development. We can start designing that API specification before we go into the backend implementation. And that way we can get feedback really fast about if the API spec will meet the user's needs before we implement. And then the key word here is enough feedback. That's always, when do we like start actually implementing? That really depends. I mean, you'll get to a point with your API specification that just makes sense to start implementing. But that's kind of the key there, is how do you know when you have enough feedback to actually start? And then the last thing here we want to do is just prioritizing based on user needs. Yeah, that's pretty much a summary of the whole list here. All right, so some of these design considerations. So when we're talking about use cases, we're talking to the consumers that might want to use this API. We need to ask some questions like, what functionality will this API help enable? We want to look at this from as far as we can, like an end-to-end perspective. So not just from the next consumer of the API, but actually what use case is that consumer of the API trying to do? Maybe maybe the API provider's downstream customer is a developer trying to use the API, but maybe that developer's downstream customer is maybe a business person or a student or faculty that's trying to use a web application that they're building. What is that full end-to-end use case, and what are we trying to enable in the end? What are the personas of the consumers? How skilled are they with interacting with APIs, or what are they familiar with? Are they familiar with APIs at all? And so on a similar note, what interaction models are they comfortable with? Are they familiar with APIs? If so, what kind of APIs? What kind of structure makes sense? There might need to be some education involved to move people to a different mode of thinking, but this should definitely be considered when designing the API. We need to understand where users currently are. And then where do they reside in the university? Are they in another department in our division? Are they a totally separate college? Are they maybe even a vendor outside of the university, or maybe another university entirely? This really makes a difference when we're thinking about API design. Some of those API design considerations, like I said already, resources and methods. We also want to think about what sort of like data sets are sent in the request and the response. So those are the request bodies and the response bodies, like the sending an order, like I showed earlier. Parameters, maybe there's different filters we want to put on to when we're getting fit data. We want to filter by certain attributes. Authentication, errors, quotas are really important too. So we need to think about what are the limits of the API. For example, how many tacos can I submit in a certain order? And then data currency. Maybe the database that the API is interacting with is basing its data off of a different database. How up to date is that data? That needs to be documented so users know what to expect, and make sure that data currency meets their expectations with what they need. So I wanted to touch on errors. I mentioned that in the last slide, but I'm really passionate about errors, so I want to make sure I touch on this a little bit more. So with errors, we really want to make it hard to do the wrong thing. We, like especially when we're creating or updating a resource, we want to make sure to spend a little bit extra time to validate that and give a user an error that they can self-correct. Not just something that says like try again later, or we didn't like your request, something that actually gives them context about how to go back and correct the request. Maybe it's for a developer, maybe even an end user that would be able to, use an error message like this to fix the request. And like I said, if we spend extra time up front validating a request and sending those errors that help for self-correction, we're saving time in the downstream with maybe invalid data that might get sent back. We're preventing that from happening. And then if self-correction is impossible, make sure we have a path to get help. Maybe the API provider has some sort of help contact or email or something that they can provide. If an error message itself doesn't provide enough context to self-correct. So for example, like let's say we were ordering, sending another taco order and we were doing too many. This is like an example error message that would allow for self-correction because it gives details about what's wrong. We can't have more than 30 tacos in an order if placed less than 1 hour. And then maybe the error message contains some additional documentation that a developer can go to understand this error better. And then after design, we want to jump into implementation. So when we're implementing, we want to focus on small vertical slices driven towards those use cases that we were designing for. So instead of like building all the database components at once, that would be an example of like a layer. We want to do, for example, implementing a single method on a single resource, and all of the API and maybe database components that go along with that. The key here is that we're working in small units of work that are really easily able to get feedback on. As long as we're able to work in that way to get that feedback faster, that's how we want to implement that API. And like I said, that feedback, does this meet your needs? Need to ask that along the way. And then, also want to make sure we're hiding the implementation details, like I said, from leaking into the API. So talk about design, implementation, testing. This is more on the developer side of the person that's providing the API, but the main goal here is that we want to create a safe environment to implement and improve the API. So we're talking about unit testing, for maybe testing that validation logic, for validating a new request. Integration testing might be testing that starts to involve a data source to make sure data is being presented in the proper way. Another thing that's common with APIs is contract testing. So that is basically asking, does our API align with its documented specification? One thing that can happen often with an API is that it kind of drifts away from what its documentation is. So contract testing helps avoid that, helps make sure those two things stay in sync. There's also some other tooling to help with that. Load testing. So this, we're basically testing an API to see, when it breaks, how much load can it take? Like the thing I like to say here is that like, every API is load tested, but some people delegate testing to their users. So, you want to make sure you're doing the load testing before your users actually do. If you have a quota set up for your API, for example, saying how many requests a person can send within like an hour, you want to make sure through load testing that your API can actually handle that quota, that it doesn't break before that quota is met. And then driven by use cases, you want to make sure the load testing, you're testing it based on how a consumer might interact with it. For example, like creating an order and checking on its status, like that would be a common use case. So you would want your load testing to kind of follow that pattern. Oops, skipped ahead. I'll just touch over this briefly. The other thing we want to do is set goals on what consumers can expect in terms of availability. So these are often called service level objectives. And when we're talking about availability, we're not measuring based on whether a server is running or something. We want to measure what actually matters for a user. So for example, back to our example, Taco API, maybe a service level objective would be a food order can be validated and submitted within 0.8 seconds. So that'd be an example of something that really makes sense to the user. The better we can meet that objective, the happier the user is. and that's how we know that we're measuring the right thing. This also helps us find the line between operational stability and new features and enhancements. So we want to make sure we're able to keep improving and adding new features to our API, but we don't want to do that at the sacrifice of its availability. So if we see that we're starting to approach our service level objective, or maybe we're even past it, we're getting slower than the goal we set, we know we need to prioritize more work to make that more operationally stable, and maybe deprioritize some new features and enhancements. This was a really high level overview on this topic, but Google wrote some good books on this, sre.google, if you want to learn more about service level objectives. This is a little bit different than a service level agreement. For an API, a service level agreement might involve things such as the quotas. It might involve other things that API consumers should expect. All right, and then jumping into the person API, I'll touch on this briefly. I'll do a quick demo as well. So our team's been working on the person API to help improve identity data integration. So we're talking about core person data elements such as like name, email, eventually like pronouns and other core data like that. Right now, the API is read-only, so you can only send GET requests, but we want to eventually have this be a way to update and create people based on or depending on the use case for that. The process for getting access to the person API is a little bit tricky right now. So we created a mock API that has the same structure and behavior as the real API, but it uses fake data. So this allows people to get a better idea of what to expect for the person API and maybe even start integrating with it before they have gone through the process to get access to it. I won't go into too much detail on this, but this is just an example of how we went through use cases and mapped those to, and eventually created the person API specification based on those use cases. So in this example, we were, like I said, we were looking at what is the eventual end user of the application that wants to use this API and making sure we're able to deliver functionality that eventually meets the needs of those end users. All right, and making sure I leave time for questions, I'll just do a quick demo here. So I'm going to jump into our developer portal, which people are welcome to visit, developer.wist.edu. But I'm just going to show an example of what the mock API looks like. So this is our home page. I'm going to go into APIs here. And then we have the mock person API and the person API separately. I'll go into the mock person API. So this is that specification that I mentioned. So all that data is here. We're still working on it, but this is an overview of what it looks like. I'll need to authenticate this request, even though it's fake data. We still require authentication just to match the behavior of the real API. I won't touch on all. Oh yeah, I already acquired that, so I won't go into detail on that just in the interest of time. But after that, we can go to a resource such as people, and we can send a GET request to people. I'll execute that, and then we can see it was 200. Okay, and then the response is down here. Our developer portal allows you to actually send requests from the browser itself. So this is an example of what the person API looks like. For example, we have email address, first name, last name. This is the structure that we have for that right now. There's some other there's lots of other features and a few other resources of the person API, but just in the interest of time, I won't go into that now. So with that, I'll move back here, and I think we can open it up to questions if there are any.
Before we get started on the Q&A, I want to let people know time check. So it's 2:28. There are sessions starting at 2:30. There's the second session of Flash Talks, and then the Stuck in Limbo Struggles and Successes with MS Graph API for Automated Email Access into O365 with Brian Wilt. So if you need to hop out and go into one of those, please feel free to do so. We'll keep working on the Q&A here. If you have questions, throw them in chat, and I will ask Jared. You can also contact Jared via email if you have questions after this, we're all dying to know how to use this person API. My first question is, it's usable now? I know you walk through how to get connected to it with the tokens.
Yeah, so right now we're at the point where we've implemented the first use case we've been driving towards, and we're looking at onboarding new consumers who maybe already access person data, but through different means. We're also, and as part of that, we're looking at for API consumers that can start using the person API based on what data it's already providing. So if you think you have a use case that maybe you're already using person data for, but want to use the person API instead, and you don't need any additional data, past what the person API already provides, then yeah, please reach out to us. Reach out to us either way. But I'm just giving that context to note that we're trying to prioritize people that we can onboard quicker, and then make sure we're taking those use cases for things that we can provide in the future.
Is it mock data as well?
So yeah, I just showed the mock person API, but the real one is using real data. So that's up and running.
Good to know. Jim put in, will the person API be responsive enough to handle look-ahead queries in a web app?
Yeah, could you clarify what you mean by that?
I mean, when you, if you're typing in, like we've got a lot of applications where you're starting to type in a person's name and it's automatically, searching our local database and just giving you the top hits. So you can, easily find and click on them.
Kind of an autocomplete kind of thing.
Yeah. So, I mean, I'm assuming, that's just making a bunch of repeated requests back. Do you envision this being that responsive to handle that type of thing?
Yeah, I think that would be a good use case. I mean, we've been trying to make requests take under a second. And we're actually going to work on a story soon to actually define what our service level objectives are. So if that kind of meets the use case that you're looking for, then that would definitely be valid from my perspective.
Great. Thanks.
Interesting use case, Jim. I like that.
Yeah.
I'd have another. Will the team be building user-specific APIs or are just general purpose? I'm not sure what's meant by user-specific, but maybe role-specific. Like I'm a programmer. Do I get something different, or is it just one API for everybody?
Yeah, I think maybe how I'm interpreting this question is that I think person API would mainly, at least initially, be used for systems wanting to integrate with person data rather than maybe someone logging in as a user and getting their data, if that distinction makes sense. So yeah, we definitely want to enable that in the future, but the nature of the person API right now is it's giving access to lots of people's data. So those are the main use cases that we're looking for. Like maybe Jim said, like something that you need to search for a person's name rather than maybe someone logging in and getting and updating their own data.
Sure. I mean, as someone that does a lot with that sort of data, it's like, how deep can we go? Can we get salary information or appointment information? Or but those are different systems and different permissions handled by different groups. So who knows where? Eventually, someday that will be all part of the same thing, but it's going to take some time. Do we have any other questions? Oh, somebody has their hand up.
Hi, this is Samya. I had a question related to what we just talked about. How do you determine the attributes that are associated with, like, say, the person API? Is it basically the user story driven or use case driven? So if you have a minimum set of attributes that you want to release with that particular API, is that really driven by the use case?
Yeah, I would say definitely. There definitely needs to be some conversation to figure out, maybe the use case is asking for specific attributes that would be, better filled in another way. But yeah, those attributes are driven by those use cases. And for the person API specifically, we're trying to align with a new group that's spinning up. I believe it's called the Core Person Data Governance Group. Those are going to going to be able to have some policy around like core person data. So we're trying to align the API with that, trying not to make it creep into maybe other domains that would be better solved by, for example, maybe a student API or an employee API. There is some overlap there, but yeah, so that's a person API specific thing, but yeah, those attributes are very use case driven.
Whew, yeah, how do you break all that down? Wow. Okay. Fun job ahead of. Do we have any other questions? Feel free to unmute and ask if you would like. There's only 25 people left here, so.
Yeah, and thank you all for staying a little bit extra time to ask questions too. I appreciate that.
If you don't have any further questions, we'll stop the recording and conclude this session. We have lots of, I think we've got 3 sets of presentations left. There's 2 that just started, and then 2 at 3:15 and 2 at 3:45, including Alan Monet's "Don't Panic: A Guide to Cybersecurity Incidents." So that'll be a fun one.
Cool.
With that,
Thanks everyone.
oh, well, that's applause, not a question. So yay. Thank you, Jared.
Yeah,
Alex.
thanks everyone.
Alex, you're going to stop recording.